yesterday, but you guys are already really good at it. We're labeling equivalent fractions and halves, okay? Well, excuse me, not and halves. We are labeling halves. Equivalent fractions to halves. Equivalent fractions to halves. We're starting with one whole on top, okay? Now listen, guys, I need everybody paying attention, okay? Because you're going to be doing this individually before we go through it together. One whole on top. You're going to label each section of the fraction bars below. Each section of the fraction bars below. Use the fraction bars to find fractions equivalent to 1/2. Okay? Find fractions equivalent to 1/2. One is at the top. That's our whole. But remember, guys, look at this. Check it out. Check this out. Every single bar, fraction bar here, right? They're all the same length, correct? Say it one more time, Heston. That's exactly right. They're just cut up differently. And that's what makes it into fractions. So let's do, okay, let me ask you guys. Do we need to go through a couple of these together before you do it on your own? Yes. Yes? Yeah, okay. Some of you are saying no, some of you are saying yes. We will go through a couple together. And that means I need everybody following along. Brewer, please turn your body all the way around toward your desk and be looking at your paper. Okay. So then what's this one then? What's that one there? Each side of it would be what? 1/2. Because there are two parts, right? Remember, the denominator, the bottom number, is the number of parts that you've cut the whole into. So in this case, you cut the whole into two parts, which means the 2 is your denominator, correct? So, everybody, remember what I said? If that was going to become distracting? Zoe, not cool. I told you if that was going to become distracting, that bracelet, that you're going to have to get rid of it, okay? So I want that somewhere else. You cannot be eating candy in the middle of class.
Wait, where did I do that?
Well, the trash can, preferably, because you shouldn't have had it out. But please put it somewhere where it will not be distracting. Okay. Everybody should be writing this down. I see some people have already gotten a good start. What about this one here? How many parts do we have this cut into? Jack. Say it again. So what's our denominator? Everybody?
3.
Okay, so that means that you know that each one of these should have a 3 on the bottom of it. What should the top number be? Brewer.
1.
That's right.
Oh.
Okay, what's the next one then? What's the next one? What's the next one? Heston.
4.
That's right. So is our denominator 4?
Yeah. Yes.
Okay, so what should our numerator be on each of them?
1.
Everybody?
1.
That's correct. That's right. Does this make more sense, guys? Now that we started doing it? You're doing the same thing for every section. Remember, the numerator is the top number, denominator is the bottom number. The denominator is always the number that represents how many parts you cut that shape into. In this case, the fraction bar, okay? So if it was cut into 1,000 pieces, it would be, each piece would be 1 over 1,000. Okay? Because the numerator represents one of those pieces. Or however many of them you have. Okay? So let's go ahead and work on this for a little bit. We will come back to it. You also have, you've got this halves page right here. And then you also have a thirds page. But guys, don't get freaked out. It's the same thing. Okay? 1/3 and 2/3.
What is the thing at the bottom?
Okay, oh, good question. So down at the bottom here is where you're going to, after you do this, glad you asked that, thank you. After you go through and you mark all these, then you're going to find what it says at the top, which is to find fractions that are equivalent to 1/2. So down here, you're going to write down next to it with a comma, because we're using it as a series, we'll have a list, of all the fractions you found above that are equivalent to 1/2. So, when we go back up, and after you've labeled it, when we go back up, you've got 1/2, obviously. Are any of the 1/3 equivalent to 1/2? I see some thumbs down. Are any of those equivalent to 1/2? How many 1/3 are equivalent to 1/2? Nope. Nope, because 1/2 is right here. 1/2 ends right here. So if you need to at the end, draw a line all the way down. Draw a line all the way down. And then you can tell which ones are equivalent. So the 1/3, none of those are equivalent. But what about Heston? Don't speak up, but what about the 1/4?
Yeah.
How many of them?
2.
Yep, so then it becomes, it's 1/4 plus 1/4, so it becomes 2/4. Because you're going to add these two together, so 2/4. So that would be one that you'd want to write down there. That would be one thing you want to write down there. But yeah, look at this line. Keep the line all the way down.
Okay, I see.
Yeah, so the first one is 2/4, right? And then you're going to keep going. You're going to talk about whichever ones are equivalent to 1/2. Yes? There might only be 3.
It goes 2 to 4 and 4, 6, 8.
Well, you're right. You can write down other ones. That's true. And then on the third page, guys, you're doing the same thing. But on that page, it actually asks you to find, you're going to label each section of the fraction bars, okay? But you're also going to find fractions that are equivalent to 1/3 and 2/3. 1/3 and 2/3, okay? Yeah? You like it? Well, you think it's easy. Maybe you don't like it, but you think it's easy. If it's easy, that's a good thing. So that means what we'll do is we'll have you guys work on this for about, I don't think we'll need until recess. I think we can finish everything before then, actually. So I'm going to have you guys work on these until about 9:50. We'll come back together. We'll do it all together. We'll review it all. Everybody should have it done by then. Then you guys will go to recess. We'll come back. We'll do ELA. And then we'll see where the day takes us. Okay? Let's see if we can get this one to work this time. Okay. So we started this one, right? We were looking for fractions that are equivalent to 1/2. So you got 2 parts to both of these. Okay? A couple things. So I want this in front of everybody on this page. Everybody. Done or not? And most of you, I think, are done. Right? Can I see a show of hands who finished the first page? Good. Can I see a show of hands who finished the second page? That means you guys did pretty much everything. I think some of you were missing some of the equivalent fractions on the bottom of the second page, but I think you all did most of the work. So I want books put away, though, for now. Just set them aside. We'll come back to them. And I want you guys to do this with me, okay? We're going to go through it pretty quickly, and then you guys will have recess. So we need to, on both pages, you have to label them first. And I'll explain again why I had you guys draw the line down the middle as well, okay? Guys, look alive. Shake it off. Shake it off. Alec, question?
Why do you have to draw the line so it can line up?
That's exactly right, because we want to line it up. Exactly.
Not lines up.
But yes, line it up. Yes, exactly. Nick.
We're going to have to do our exercise.
Yeah, we didn't do that today, but we don't have time right now, and you guys are about to have recess, so I think we're going to be okay. But, okay, so now we have 1/2, 1/2, 1/3, 1/3, 1/3, 1/4, 1/4, 1/4. Now, what is our next one? How many parts do we have here? Don't look at the line right there. How many parts do we have this cut into? How many parts do we have that cut into, Alex? 5 of them. So is that our denominator?
Yes.
And our numerator should be what? Because they're each individual, right, Heston?
1.
That's right. So each one of these is 1/5. How many do I have this one cut into?
6.
The next one.
6.
Is our denominator?
1.
No, denominator.
6.
That's right. What's our numerator?
1.
Yes, that's right. Each one of these is 1 part out of 6. That makes sense, right? 1 part out of 6. Imagine these are like giant Kit Kat bars, and every time I'm cutting them up.
Okay, since our video in class got cut off, I figured I would go ahead and add a little section here so we can see the bottom and make sure this is in our complete video. That's the Colonel, my rooster outside, saying hello. So we already have our 1/6 here. 1/6, 1/6, 1/6, 1/6, 1/6, 1/6, right? Now we need to look at this one. We have 8 parts in total, which means because we have 8 parts, our bar here is cut into 8 parts. That is our denominator. Okay, so that means each one of these is going to be out of 8. Our denominator will be 8 on every single one of these because we have 8 parts. And just like all the others, 1 part out of 8 is going to be 1/8, 1/8. So every single one of these will be 1/8. Now, remember, and I keep saying this, when you add these together, which is essentially what we are doing here when we're talking about equivalent fractions, you are not going to change the denominator. Do not ever change that bottom number when you're adding fractions, okay? We are only going to change the top number when you have 2 like denominators, meaning 2 denominators that are the same, okay? So let's take a look at that. Now, I had you guys draw lines on the other page for the 1/2, and this time we're going to draw them for the 1/3. So you don't want to line straight down the middle. You want lines where the 1/3 and the 2/3 are, right? So 1/3 will be here, straight down, and 2/3 is going to be over on this side, straight down, right? So we're going to continue those all the way down here, just like that. Now, remember what I said before. If you see a fraction, one of these parts here, getting cut off, that's a really good sign you do not have an equivalent fraction there, right? You really want them to line up. You want them to line up. So the ones we want to line up with 1/3 are going to look like 1/3. So that means our only option here would be these 2 1/6 parts. Now, remember, 1/6 plus 1/6 is going to be 2/6. So we'll go ahead and we'll write that right here. Now let's take a look. What about 2/3? That's both of these parts right here. That's this one and this one. Well, now we want something that's going to line up with that. Well, we're looking at the same thing. We're back down at our 6th here, right? And that's another 2/6. So in this case, we're going to do 1/6 plus 1/6 plus 1/6 plus 1/6, which is going to give us 1, 2, 3, 4, 4/6. 4/6. If I can say that, that would be helpful. So now we have 4 parts here, right? 4 out of 6. 4 out of 6. And you can see they line right up with the 2/3 up here. 2 1/3, right? Just like this. And that's what we're looking for. And really, we could continue. We could keep going. We could keep going for quite some time. Forever, in fact, if we wanted to continue our fractions, we could keep finding more and more equivalent fractions. Now, some of you have pointed out to me that there are patterns here as well, and that's exactly what I want you to see. Let's take a look at these really quickly, for instance. Up here, now you can see on this one I hadn't finished it, but let's add those in. So we have 1/5, 1/5, 1/5. It's cut in half, right? So we know that's not going to be an equivalent. 1/5, 1/5. We have again 1/6. And we've got the same all the way across here. Each one of these. And I've gotten questions about this before, but remember, if I do a slash like this or a line straight across like they have down here, that's the same thing. This is just how I like to write out my fractions. 1/8, 1/8, 1/8. These are all eighths, right? Now, of course, in this case, we're doing halves. We're looking for equivalent fractions to 1/2. So we have this green line straight down the middle here. Well, let's go ahead and switch back to our green and take a quick look here at what our other equivalent fractions were, right? So we had 1/2 to 2/4. That was clear right here, right? But now we also have sixths here. 3 of them, in fact. 3 of them. So let's go like this. Plus, plus. Now we have 3/6, right? 3/6. And again, I know we went over this in class, but I'm going to go ahead and draw them in here anyway. And then, of course, down here we also have more equivalent fractions. 1, 2, 3, 4/8. Okay. Now, here's where one pattern is. Look at the numerator. 1, 2, 3, 4. They're going up 1 each time, right? The denominator is going up by 2s. 2, 4, 6, 8. Those are multiples of 2, right? We're going up by 2s. We're counting by 2s. Skip counting by 2s. So what we could do is we could also say that, okay, well, if that's the case, then that means our next one would be 5 out of 10. And then 6 out of 12. And then 7 out of 14. Now, the halves are nice because you can also look at them differently, right? You can say, well, this is easy because, of course, 2 out of 4 is 1/2. 3 out of 6 is 1/2. 2 is half of 4. 3 is half of 6. 4 is half of 8. 5 is half of 10. 6 is half of 12. 7 is half of 14. And so on. And that helps you if you can see it that way, right? Same thing is if you look at, or excuse me, another way is if you look at it this way. 4 divided by 2, right? 4 divided by 2 equals 2. 6 divided by 3 equals 2. So we know we're going up 2 each time in the denominator when we're looking for these equivalent fractions, okay? So, and remember what I've said in class here. If we were going to do something like 4 divided by 2, let's say we were trying to simplify this when we said 4 divided by 2. Whatever you do to the denominator, you're going to do to the numerator here, okay? So, 4 divided by 2 equals 2. Right back over here. And 2 divided by 2 equals 1. Right back over here. So what we did here was we found a common factor that you could divide the two of these into to simplify it. So when we look at equivalent fractions, we're also looking at the ability to simplify. Our simplest form for any of these is going to be the 1/2. Okay, so in this case, you're not going to do 6 divided by 2. You can do 6 divided by 3, though, right? So 6 divided by 3 equals 2. Right back over here. And then, of course, 3 divided by 3 equals 1. And the same is true for every single one of these. 8 divided by 4 equals 2. 4 divided by 4 equals 1. Same thing every time. So let's take a quick look down here, and let's look at the pattern down here. We're seeing something really similar, right? Except this time, because we're looking at thirds, we are not counting by 2s, right? Our numerator is still going up 1 each time, at least for the 1/3, right? 1, 2, which means the next one would be 3, 3, 6, 9, right? And then 4, 3, 6, 9, 12. We are now skip counting by 3s. These are multiples of 3. Down here, our numerator is going up 2 times. Each time, 2, 4. Next one is going to be 6, but we're still going to have a denominator of 9, right? And then we're going to have a denominator of 8 and a numerator of 8 and a denominator of 12. Okay? And this works every time. But, of course, the difference here is what I showed you above. We have to look at it slightly different when we're down in this area. Okay? So in this case, if you were to take 6 and divide it by 2, of course, you're going to get 3, right? So we would say 6 divided by 2 equals 3. 2 divided by 2 equals 1, right? Now, let's take a look and see what happens if we apply our formula here to the next one. Well, we want to do 9 divided by 3 then, correct? So 9 divided by 3 is going to equal 3. And 3 divided by 3 is going to equal 1. Okay? We're going to go up again, right? One more time each time. Divided by 2, divided by 3. Now we're going to divide by 4. And of course, the hint is, look at our numerators. That's really what we're doing, is dividing our denominator by our numerator, right? So 12 divided by 4 equals 3. 4 divided by 4 equals 1, okay? But what about down here when we look at the 2/3? What can we do here? Can you divide 6 4 times? No, you can't. So if we're looking to do something like like this, then we're going to switch things up a little bit, okay? What we're going to do is we're going to start with 2's. 6 divided by 2. We're going to do half of our numerator for this one, okay? 6 divided by 2 equals 3. 4 divided by 2 equals 2. Then we're going to go up again. You can't do 9 divided by 6. It doesn't work. But you can do half of 6. 9 divided by 3 equals 3. 6 divided by 3 equals 2. Okay? And the same pattern also applies. Switch back to a different color here to make this a little easier. Maybe not the same color, though. That wouldn't make things easier, would it? Right here. We can't do 12 divided by 8. It doesn't work. But we can do, again, look at our pattern. 2, 3, 4. 12 divided by 4 equals 3. 8 divided by 4 equals 2. Okay? So hopefully you can see the patterns here. This has gone a little bit further than what we did in class, but we have talked about this before. But it's a good thing to kind of get in the practice of understanding because we are going to go further into this, okay? If you have questions, just let me know.